Hi, I'm John McGinley. Welcome to the CPL Pipetting tutorial. Today I'm going to talk about air displacement pipettes that we have in the laboratory. We have four major brands: Gilson, Rainin, Eppendorf, and Hamilton. I'm going to be focusing on the Gilson pipettes. We have four sizes of these pipettes: the P10, P20, P200, and P1000. The size of the pipette is indicated on the top push button right here that I've outlined in red. So the P10, the range for a P10 pipette is from 2 to 10 microliters. A P20, it ranges from 2 to 20 microliters, but typically we only use it for 10 to 20 microliters since we have a P10 pipette for the smaller volumes. A P200 pipette ranges from 20 to 200 microliters, and a P1000 ranges from 200 to 1000 microliters. Looking at the parts of the pipetter, at the top there's the push button, the plunger, the tip ejection button, the volume control wheel, the volume indicator window, a hand grip, shaft, the tip ejector, and a pipette tip. Three things that you don't want to do. You never want to turn the volume control wheel above the maximum volume for the pipetter. For example, if you have a P1000 pipette, you don't want to go above 1000 microliters. Likewise, for a P10 pipette, you don't want to be going above 10 microliters. You also never want to invert a pipette. And you never want to lay a pipette on the bench with the tip on, especially if there's any fluid in the tip. You just don't ever want to do that because you could have the fluid flow backward into the shaft and it could ruin the seal or the piston. So pipettes should always be in a pipette stand when not in use. Here's an example of a P1000 pipette that is currently set for 500 microliters. Here are two examples of pipette tips that will fit the P1000 pipetter. Over on the left-hand side are non-filtered tips, and on the right-hand side are filter tips, or barrier tips as they're sometimes called. The red arrow, you can see the red arrow pointing to the filter within the pipette tip. Here's an example of a P200 pipette that is currently set for 100 microliters. Here's a P20 pipette, which is currently set for 15.5 microliters. Here are some examples of pipette tips from USA Scientific for the P20 and P200 pipetters. Both sizes actually have the yellow colored tray, but the size is actually indicated, stamped on the front left-hand corner of the tray itself, so that way you can distinguish between the two different sizes. Here's an example of a P10 pipette that is currently set for 4.2 microliters. Here are the tips that fit the P10 pipetter. Over on the left-hand side, we have non-filtered tips, and on the right-hand side, we have filtered tips from USA Scientific. I wanted to spend a little bit of time going over the Rainin L2 pipette, which we use quite a bit in the laboratory for nanodrop and Experion instruments. It has a range of 1 to 2 microliters, and in the center you can see the compatible tip box. Those tips have a range of 1 to 10 microliters, and the pipetter, you can see on the right-hand side, it's currently set for 2 microliters. Let's spend a little bit of time talking about adjusting the volume on the pipetters. When increasing the volume from the current volume setting, you'll want to turn the volume control wheel about 1/3 of a turn above where you want to set the volume for the pipette, and then back down to that desired volume. Likewise, when you're decreasing the volume from the current setting on the pipetter, you'll want to turn the volume control wheel down to that desired volume and do not go beyond that point. So you can see in that center image, I have volume setting control window displayed for a P200 pipetter, and it is currently set at 131.5 microliters. Now keep in mind that that very bottom setting between 1 and 2 microliters, each one of those hash marks is 0.2, and there is a little blue arrow that's at the bottom of that window, and it's pointing upwards right between the second and third hash mark, which would be at a level of 0.5 microliters. So that's where we get, reading it from the top down, 131.5 microliters. Also, you want to make sure and check the volume window periodically to make sure that the volume has not shifted any while you're pipetting. This is especially true if you're pipetting replicates or aliquots. You're doing repeated volumes for a longer period of time. Looking at volume settings across all the pipetters that we've discussed so far in one slide, starting on the left-hand side, we have the P1000 pipetter that's set for 500 microliters, followed by the P200 pipetter set at 100 microliters, P20 set at 15.5 microliters, a P10 set at 4.2 microliters, and an L2 pipetter set for 2 microliters. Here are examples of microfuge tubes that we use in the laboratory. Starting on the left-hand side, we have a 2, 1.5, 0.5, and 0.2 ml tubes. Here are two things that you don't want to do that will damage the pipetter. Don't hammer the pipetter into the tips like this. Don't pop the pipette by letting go of the button too quickly, like this. Here's the correct way to pick up a pipette tip, using a downward twisting motion to seat the tip. Nice and easy, not hammering into the tip box at all. Just like that. In ejecting the tip, you want to move the pipetter over the trash can or waste receptacle and then press the tip ejection button, just like this. There are two different pipetting techniques. Forward pipetting, used for most applications that most people are familiar with, and reverse pipetting, that's used for pipetting replicates, aliquoting, or for pipetting very small amounts. Now the pipetter has three different positions. There's the release at the very top, there's a first stop, and a second stop. And the first stop and second stop are used differently in these two different pipetting techniques. Here's an example of pipetting down to the first stop and back. Nice and smooth, just like that. Here's another example of pipetting down to the first stop, then to the second stop, back to the first stop, and then home. In the forward pipetting technique, press the plunger down to the first stop, immerse the pipette tip into the liquid that you're going to be pipetting from, slowly release the plunger back to its home position to draw the fluid up into the tip. Then move the pipetter over to the tube that you're going to be pipetting into, place the tip along the inside wall of the tube, and press down to the first stop to dispense. Hold it there for a second, and then press down to the second stop to dispense any residual fluid that may be left in the tip. Here's an example of a forward pipetting technique. So you can see that I'm bringing the pipette over, I'm keeping it straight, drawing the fluid up, and then bringing that over to the tube and dispensing into the tube, just like that. The reverse pipetting technique is a little different. You want to press the plunger down to the second stop, immerse the pipette tip into the liquid that you're going to be pipetting from, then slowly release the plunger back to its home position. It's a good idea to pre-rinse the tip a couple of times. So you're going to be dispensing back into the tube that you're going to be pipetting from, drawing that solution back up, pipetting it back down into the tube. Do that a couple of times. Pre-rinsing the tip will help to maintain consistency when you're making replicates or aliquots. So once you've pre-rinsed the tip and you've got fluid back up into the tip and you're ready to dispense, move the pipetter over to the first tube that you're going to be pipetting into, place the tip along the inside wall of the tube, press down to the first stop to dispense, and then hold it at the first stop. Don't go back to the home position or release the pipette plunger. Keep it held at that first stop. And go back into the fluid that you're pipetting from, immerse the tip back into the fluid, draw that back up to the very top, move over to the second tube, and then dispense, and then keep repeating that process until you're done. Here's an example of reverse pipetting. So I'm bringing the pipetter over to my tube, keeping it straight, drawing up the solution that I need, correct volume. So now I'm going to pre-rinse the tip a couple of times, just like this. And now I'm going to draw up again, and I'm going to go into my first tube, and you'll notice that there's a little residual volume of fluid that's left in the tip each time. And that's what you want when you're doing a reverse pipetting technique. You want to see that residual volume, just like that. Tip ejectors on these older pipettes have a tendency to slip sometimes, and so you'll want to check the gap periodically to make sure that there's distance between the pipette tip ejector and the pipette tip. You can see over on the left-hand side is an example of an ejector that is right up against the pipette tip, drawn with the red arrow. And that's not a good situation because it means that the pipette tip is not being seated correctly. So to adjust for this in the center image, you would just apply upward force on the pipette tip ejector to push that back up into the grip. And over on the right-hand side, you can see that after that's done, that there's a proper gap between the pipette tip ejector, that metal piece, and the pipette tip. You want to watch out for any air bubbles that may have formed in the solutions that you're pipetting. Over on the left-hand side is an air bubble that is in the center of the pipette tip. It's indicated with the red arrow. In the center image is an air bubble that is at the bottom of the pipette, likely a result from withdrawing the pipetter too quickly from the solution. And over on the right-hand side, you can see the volume has no air bubbles, either in the center or at the bottom. And this is what you want, is correctly pipetted solution. Don't tilt the pipette or the microfuge tube when aspirating fluid. You want to keep the tube and the pipette as vertical as possible, as shown on the right-hand side. Don't hold microfuge tubes with a clenched fist for two reasons. One, you can't see the volume of the solution that you're pipetting. Second reason is if you're working with something that needs to be kept at a colder temperature, your fist is going to be warming that solution up too quickly. What you want to do is to hold the tube between your index finger and thumb with your palm facing toward you, and this way you can actually see the solution that you're pipetting out of the tube. Immersion depth is important when it comes to air displacement pipettes. We have to keep in mind that the volume that we're pipetting is actually riding on a cushion of air. It's affected by air pressure. You can see in the illustration on the left-hand side that the pipette tip is all the way down on the bottom of the microfuge tube, and this is incorrect because that difference in pressure is going to affect the volume that's pipetted. Over on the right-hand side, this shows the correct illustration of pipetting. You want to keep the pipette tip about 2 to 3 millimeters below the surface of the fluid and don't go beyond that. You want to make sure that the tube contents are mixed thoroughly. And so to do this, there's a couple of different methods you can use. One is to use a new pipette tip, and using a reverse technique is to mix the solution up and down about 10 times, avoiding air bubble formation. You can do that, or you could use a vortexer to vortex the microfuge tube for a few seconds, and then use a mini microcentrifuge to spin the contents down. When pipetting into a 96 well plate, always make sure to use a plate stand, which will tilt the plate at an angle and make it much more comfortable for you while you're pipetting. Over on the right hand side is an example of a 96 well plate, and you can see in wells A1 and A2 there are two small blue dots. Each one of those dots represents a 5 microliter volume that has been dispensed into each one of those wells. And you can see that the dispensed volume is not in the center of the well, but it's actually lying at the bottom edge of the well. And that's where you want to be pipetting your samples, your replicates, is into the bottom edge of each one of those wells. I'm going to take a moment to talk about multi-channel pipetting. Let's say that we've had our samples that we've pipetted using a plate stand, 5 microliter replicates that we've been pipetting. Once that's done, we would remove the plate from the plate stand and lay it flat on the bench top. And at that point, you would grasp the top left and bottom edges of the plate as indicated on the left-hand side to hold that plate still. And then with the right hand, over on the right-hand side, you can see an 8-channel multi-pipette that is dispensing fluid into all 8 of those wells at the same time. You want to make sure that before you actually dispense a volume from a reservoir, as you're drawing the solution up into the pipetter, you want to make sure that all 8 of those channels have the same level all the way across in all the pipette tips. If they don't, discard the tips, get a new set of tips, come back into the reservoir, aspirate the fluid that you want, make sure it's at the same level, and then pipette into the 8 wells. Plates also need to be mixed as well as tubes, and a good way to accomplish this is using an orbital shaker. You can see in this illustration there's an orbital shaker that has plate clips that would accommodate up to 4 96 well plates on one orbital shaker. Take a moment to talk about ergonomics. Make sure the area you're working in is well lit to avoid eye strain. You need to be sitting down while pipetting. Don't be standing up, hunched over the bench top. That's just not a good position to be in. So make sure that you're sitting down and adjust your chair to the proper height. You also want to make sure that you have plenty of leg room and that you're not in some kind of odd contorted position. You want to keep your head and torso aligned vertically. You want to hold the pipetter using a relaxed grip, and then you want to keep your wrist straight also. You also want to keep items on the bench top easily accessible so that you're not overreaching. Hold the tube and pipette at eye level when aspirating and dispensing. Rest elbows on the bench top and take micro breaks periodically to avoid fatigue. And what I mean by this, by micro break, is as you're pipetting and you're feeling fatigue coming on, just take the pipetter and put it back in the pipette stand for just a few moments, and then kind of pump your fist open and closed to get the blood flowing again, and then go back and grab the pipetter to continue. Okay, some things that you don't want to do. You don't want to be handling microfuge tubes and pipette tips with your bare hands. You don't want to invert a pipette or lay a pipette on the bench with the tip on. You don't want to pop the pipette. You don't want to rotate the volume control wheel beyond the maximum. You don't want to be hammering pipette into the pipette tips. You don't want to be tilting the pipette when filling or aspirating. You don't want to be holding the microfuge tube in a clenched fist. You definitely don't want to be using a death grip when you're holding the pipette. And you definitely do not want to keep tube bags open when they're not in use. Some things that you do want to do: you do want to be wearing a lab coat and gloves and eye protection while pipetting. You want to spray down the bench top with 70% ethanol before and after use. When working with RNA and DNA, you'll want to clean the bench with RNA away first, followed by 70% ethanol. Make sure to clean your gloves with 70% ethanol. Pour microfuge tubes from the bag into a gloved hand or clean bench top. You'll want to keep pipettes in a pipette stand when not in use. Hold the microfuge tube and pipette vertically when aspirating fluid, and you'll want to keep the pipette tip just below the surface of the fluid, about 2 to 3 millimeters. When dispensing fluid, place the tip against the inside wall of the tube and then dispense. When purging, be careful not to be introducing air bubbles into the solution. In reverse pipetting, for replicates and aliquoting, make sure to pre-rinse the tip a couple of times. You'll be wanting to check the volume window periodically to make sure the volume has not shifted while you're pipetting, especially if you're pipetting for a longer period of time. And you'll be wanting to take breaks when pipetting for long periods. This brings us to the end of the CPL pipetting tutorial. I hope you found it useful. Thank you.